Lesson 4.6, Power Rule Level 3. Given the function f of x equals negative 5 over x minus 5 times the square root of x cubed over 3, find f prime of 4. So they're wanting us to find f prime, the derivative function, but then also find it exactly at 4. Express your answer as a single fraction in simplest form. So my first job on these would be to rewrite the function. So I'm going to say f of x really equals, this is negative 5. I want to bring x up, so now it would be x to the negative first power, minus, this is 5/3, times x to the 3/2. Okay, now I want to find the derivative. So f prime of x, I would have negative 1 times negative 5 is 5. X to the subtract 1 would be to the negative second. Think about what happens if you take 5/3 times 3/2. What did I write to? 5/3 times 3/2. Your 3's would cancel, so it's 5/2. Going to be minus still. X to the, think about 3/2 minus 2/2 would be positive 1/2. Okay, then let's rewrite that so that it looks a little nicer. I'm going to drop the x squared down. And then this would be minus 5/2. And then times the square root of x. I'll put it on the top. And now we want to figure out at 4. So I'm just simply going to plug 4 in. Which would equal 5, oh, come over here. 5 over 4 squared would be 16, minus 5 times square root of 4 is 2, that'd be 10 over 2, which that's really 5. So we get 5/16 minus 5, which is over 1. I have to have a common denominator, so I'll make them both be out of 16. 1 times 16 gives me 16. 5 times 16 is 80. And then all I have to do is 5 minus 80 would give me negative 75/16. As long as there's no common factor to be divided out, that's what they're wanting us in simplest form. You don't have to change it into a mixed fraction. Okay, and then number 2. First, what I would do is take our function and rewrite it. So it'd be f of x equals, this would be x to the 3/2 power, plus, there's a 1 here in front of the square root of x, so I would write this as 1/2 x to the 1/2. And then we need to derive it. So bring the 3/2 in front. I'm going to subtract 2/2, which would be 1/2. And then I will take 1/2 times 1/2, which doesn't cancel, that actually gets me 1/4. X to the negative 1/2. So let's write it nicer. This would be 3, I'll put square root of x on top over 2, plus 1 over 4, and then this would be square root of x in the denominator. What I would go ahead and do right now is plug in the x value they're giving you, which is 3. So we have 3 times the square root of 3 over 2, plus 1 over 4 square roots of 3. If you could simplify the radical, you would need to go ahead and do that, but since we have square root of 3, there's no perfect square inside of that, so we're good to keep it, square root of 3. But since we're adding fractions, we have to have a common denominator. So you're thinking between the 2 and the 4, our common denominator would be the 4, because we can take 2 times 2 to get 4, but it also has to have this radical 3. So let's go ahead and say we need both fractions to be 4 square roots of 3. Because remember, you can always multiply to make things more or bigger, but you can't make things smaller when you're getting a common denominator. So 2 times a 2 would make a 4, then times square root of 3. So I'll have to take this times 2 square roots of 3. When you are multiplying, you multiply the numbers that are not under the radical. So we'll take 3 times 2 is 6. Then we'll take numbers under the radical and multiply. 3 times 3 would be the square root of 9, which puts us back to a normal 3. So I'll have to take 6 times 3. And then this can stay because it already has the common denominator. Well, 6 times 3 is what, 18? 18 plus 1 would be 19 over 4 square roots of 3. Now, I don't really like leaving it like this because it has a radical in the denominator, but Delta Math will take that as an answer. If it bothers you, you can fix it by multiplying by the square root of 3 on top and bottom, because this is really a 1 in disguise. Multiplying by 1 doesn't change the value of anything. So that'd be 19 square roots of 3 over 4 times, this would be a normal 3, would be 12. So this answer or this answer will get it correct.